So it's a limit of something that would equal one of those cases where the limit doesn't exist. So you'd have to find either infinite, negative infinity, or DNE.
Do you have an example? I think that's the best thing to do.
There was an example on the homework. What was it? It was
on the homework, on the written homework, on web-assigned homework?
The written one.
Okay.
From Tuesday.
That's fine. So what I would like to work on that particular ones. So did I post solutions for that one yet or not yet?
I don't believe it was just yet.
Because it's due today, right?
Yeah, due today.
Okay, yeah, I'm ready.
Let me pull it up. I have it on another tab.
Okay.
The problem was number 40, where it was a limit of 1 over x minus ln of x, where x approaches
1 over x minus natural log x, right? This, yes.
And x approaches 0 from the right.
Okay.
So in that case, where
very good.
You would want to find where.
So first of all, we have to identify where these are going.
Mm-hmm.
Good. So where is this going when x approaches 0 from the right?
It would be, well, if you enter the 0 as the x, it would be 1 over 0.
We have to memorize these functions. If we don't memorize them, we can't move forward. We graphed both functions. So can anyone tell us where does 1 over x go?
To infinity.
Very good. Can anyone tell us where does natural log x go? We graphed the function negative infinity. Since there is a negative in front, what happens to this? Infinity. How much is infinity plus infinity?
Infinity.
Good. Next question. Anything else? That's why we graph those functions, so you can have them in your at your fingertip at all times. Anything else? Other questions?
I did have a question.
I'm ready.
On the WebAssign.
Yes.
It was question 4. For some reason, I couldn't get part D.
On 2.2?
Yes.
Good. So let me open. Let me look at 4. I'm going to look exactly at yours because there were different problems. Was that Sean?
Yes.
Okay. Let me look at problem 4. Okay. Problem 4 in 2.2. Okay. One, two, three, 4. Yes, which part?
Yes. Problem D, part D.
Okay. So what was the problem with f of 2?
It looked to me that it did not exist.
F of 2? What do you mean by f of 2 does not exist?
Well, maybe I'm looking at the graph wrong, but I didn't see where the function of 2 has. From the left, it's on my graph. It looks like it's.
Well, I don't see in part D. I don't see the operator limit. Part D does not have the operator limit, does it?
No.
So why are you applying the limit if there is in the question there is no operator limit? You understand my point?
Not fully, no.
So we're asked to find f of 2. How do you find f of 2? What do we need to do in order
find
to?
where 2, plug in 2 is X.
We are looking at the graph. Is it
And-
problem 4 or I misunderstood?
It is, make sure yes, problem 4, part D.
Okay,
Yes.
so can anyone tell us how much is f of 4 on this graph?
Should be 3.
Very good.
Yeah.
So f of 2 is 3 is right here. It's the full point. The function is undefined at 4 because there is no full point at 4. But at 2, the function is 3. Is that okay?
Because the point's included. Okay, I
Good.
see.
Good. Anything else? Other questions? Sean or anybody else? Other questions? Okay, in that case, I'm going to go back to section 2.3. I'm going to share my screen. Where are you guys? Okay, I share my screen. I see you. Okay. So we only looked at one problem. So last time, yeah, I recycled my papers, but I just wanted to show again and look again at which problem that was. So we only looked at one problem, and the problem was 27. So let's choose something else. So that was 27, this one. So let's look at anything else that you would like to look at and then continue, because we have other types of problems here. And we have something called the squeeze theorem that I need to present. But before that, so tell me whether you want to work on any of these problems. So the question was asking us to find the limit if it exists from 11 through 34.
We do 33.
33. Let's continue with 33. Very good. So 33 is limit as h approaches 0 from x plus h to the third power minus x to the third divided by h. Perfect. Okay, so in this problem, I see the difference of cubes. So let's review the difference of cubes. And the formula is a cubed minus b cubed. Anyone remembers what does this factor into? And I'm going to start by giving you a hint. There is a binomial here and a trinomial here. Anyone will give it a shot. It's okay if you're wrong. I'll help.
Is it a minus b?
Exactly.
And then,
If this is a cubed minus b cubed, this must be a minus b. Definitely. Good. Here. Square this.
is it
Yes?
would it be positive now? And then plus,
Yes. Yes.
ab.
Exactly. Just the
B squared.
product. Very good. And then b squared. Excellent. Great job. Who was that?
Elena.
Thank you. Great. So this is my A right here, and this is my B. So I will just follow this pattern to factor. Now stop, because I jumped and I said we don't do anything before we plug it in. So can you tell me where does the numerator go and where does the denominator go? Even I got carried away. Excited about this difference of cubes. Where does the numerator go? Anyone? RJ, where does the numerator go? RJ, are you with us?
Yes.
Where does the numerator go? Rihanna? Where does the numerator go?
Like a
Re-
negative minus a negative, so negative.
How do we get the limit at the top? Rihanna, how do we get the limit at the top?
You plug in the 0.
Good. So what do we get?
You get h, right? Oh wait, no.
What are you plugging in?
You plug it in for x.
But what does the limit say?
Oh, sorry, h. You plug it in for h, so you get x cubed minus x cubed.
Excellent. What is it?
X cubed minus x cubed.
Yes.
I'm not sure.
You have an
Yeah.
apple, you give it to me. How many apples are you left with?
Oh, 0.
Good. What about the denominator?
H. 0.
Excellent. So there is hope. Great job. Okay, good. So now I will continue with factoring. Thank you very much. Limit as h approaches 0. H in the denominator. This I know. This whole thing. This is a and this is b. X plus h minus x is the first. X plus h minus x. Then I have this term that it has to be squared. X plus h squared. And then plus x times x plus h. And plus x squared. Good. What happens next? What do you just say? Well, you have to do this, and I will do it. Anyone?
I have a question.
Yeah, please.
I got a little lost on that last part where you have x times x plus h.
It's the middle part, A and B. This is A and this is B.
Oh, okay. All right, thank you.
That's why I put them at the top. This entire inside is A and this X is B. Is that better?
Yes, thank you.
Perfect. How do we continue? Christine, what do you think?
Are you gonna do what's inside the parenthesis first
No,
on the right?
no. You'll see in a moment why. But it's not a wrong idea. It's not a bad idea. It's not wrong. But look at anything else.
The x and the minus x.
Right, of course, these two go away as expected. Terms without age must go away. And now this age with this age will go away. I'm not going to do it here. That will not be nice. So this is age approaches 0, age in the numerator. Age in the denominator, this will go away because these two go away and this is the only factor remaining at the top. Notice that the limit operator did not disappear. I did not apply the limit yet. Good. So now all is left is this piece. Can anyone apply the limit and tell us step by step what to write? And now the limit operator will go away. I haven't heard from Isaac, from Ethan, Gia, and Janelle. Anything?
I was the one who responded and I asked the question.
I'm sorry? Say it again.
I asked the questions and I responded to it previously.
Okay.
Yeah, I responded to a question too.
But try it again. We have it's a 2-hour class. Everyone will be asked more than one question. Ethan, Brian?
All right, so I got lost in that discussion. What is your question again? I'm sorry.
Let's apply the limit and see what we get.
So if you apply the limit, that means I'm going to substitute the 0 into the x's. So I'll get h squared over 1.
What does this say? You cannot do
As it
what we cannot do what we want to do. We have to do what this says.
Well, you said as it approaches, but last time you said that last week, and you said to substitute the thing in, so that's what I did.
H equals to 0.
Oh, h is 0, sorry. So
Yeah,
x squared, yeah, so x squared plus x squared plus x squared, so it's 3x squared.
That's it. That's what I said. We cannot do whatever we want. We have to do what this says. Great job. This
Sorry,
is
I
it.
was wrong, my bad.
No worries. No worries.
Can you go over that part again, please?
Just replace h by 0. What do you get here? What do you get here when you replace h by 0?
X squared.
What do you get here when you replace h by 0?
X squared.
Good. Is that okay?
Okay, thank you.
Good. So I'm sharing my screen. Is there anything else you would like to look at?
So does that mean that the limit, like the answer to that limit would be 3x squared?
That's it.
Okay.
It's the limit. It's a difference quotient for x cubed. That's exactly what this means. It's a difference quotient for x cubed. X plus h cubed minus x cubed over h.
Can you do 24?
24.
Wait, I'm sorry. Can we hold on this for a second? How did you know to do the left side first? The x plus h minus x. How did we know to factor that stuff out?
Because when we
Right
first
there.
talked about the difference quotient, we said that x terms without x have to go away. And then the next step, h has to go away. And this is, I'm just looking, I'm not going to look at this first. I have to look from left to right. And when I look from left to right, I see that these two go away.
Okay, so it's just like process of elimination, just following the steps. You're like,
I cannot start looking from here. I have to start looking from here.
okay.
So I'm looking here, these two go away, then these two go away, and here there is nothing I can do anyway. Okay, our next problem from this set, and then we'll continue, is 24. You pick 24, so in 24 we have limit as x approaches 2, 2 minus x divided by the square root of x plus 2 minus 2. Perfect pick. Thank you. Okay, so where does this go? Ethan, I haven't heard from you. Ethan, are you with us?
Yes, I am.
Good, I'm ready. Where does this go?